So, hello, it's a pleasure to present for you the food matrix, exploring food types, composition, and nutrient assimilations. I'm Lorna Ryan. I'm a clinical nutritionist and nutritional therapy and lifestyle medicine practitioner, and I specialize in hypermobility and Ehlers-Danlos syndromes. You can read more about my work on this slide should you wish. So, what we're going to cover today is the food matrix, the groups and composition of food, digestive process, and nutrient assimilation, and of course, all through that consideration of Ehlers-Danlos syndromes. So, when we're looking at the food matrix, we're looking at chemical and physical components and the molecular relationships of food, digestion, absorption, and we're really trying to consider how food is scale sensitive and compound specific. And what we're really wanting to try and understand is that all the elements of food can affect human health, and it may or may not improve diet quality and mitigate diet related illnesses. And what's very important is to understand the food matrix can be absolutely inclusive of all cultures, personal differences, and we don't ever need to assign good or bad foods. The importance is a total diet. What we're wanting to understand through the food matrix is nutrient density, composition and bioavailability of nutrients, and actually how we can have an opportunity to modify dietary interventions. So, what we're looking at is how we use food through oral processing, flavor perception, which is how it tastes in the mouth, digestion, which is our gastrointestinal system, absorption, and metabolism. So, metabolism is that big orange square there of actually the end result of how we're using our food for energy and nutrient absorption. And we have nutrient in going through all of this matrix, forms, textures, and composites to get to our end result. And this might not be of great surprise to many people looking at the food groups, the macronutrients, but it's important to just understand that the big guys of food are our macronutrients of carbohydrates, lipids, proteins. And the carbohydrates might be simple or starchy and complex, which would be more of sort of the root vegetable styles. Fats can actually be split down into 4 subtypes, and you may have heard that saturated trans fat or polyunsaturated. So what we actually term in the food matrix as fats, we refer to them as lipids, and that can be also known as fatty acids. And then proteins can also be known as amino acids, and you might have heard that term quite frequently. Once we start looking down into micronutrients, what we're considering is how all of our foods come together in a colourful mix, and they're containing an abundance of vitamins, which can both be soluble in water or soluble in fat. And whether they're water soluble or fat soluble affects how the body might use those nutrients. We've also got macronutrients and trace minerals, and you might have heard about trace elements referring to electrolytes. So this diagram nicely depicts all the colours involved in food that forms a healthy, balanced diet. And all of those letters and numbers are signalling the vitamins. So Ca, for example, is calcium and Mg is magnesium. And this picture really does show how there's a lot of micronutrients in an abundance of food types. We can take a step further to look at the chemical makeup of food. So we have the macronutrients, micronutrients. But actually, if we put all the food together, we extrapolate the composite of it, so the composition. And it includes phytonutrients or antioxidants, sugars, and waters. In this diagram, if you want to zoom in your own time, you can see how we can be considering things like enzymes, things like minerals, and you can see there again that Mg from magnesium. We can also be looking at the flavonoids, which are the antioxidants. And so what we're trying to get a good idea of is every single food has a chemical makeup that includes many different compounds. And we're then going to zoom in even further to look just at dietary fiber. So this is a complex group of substances. There's ingestible fibers, there's fermentable fibers, and fibers are really easy to manipulate when you understand them. So this goes back to the food matrix, offering an opportunity to manipulate dietary interventions. So you've just got the 4 big guys of dietary fiber here, and if you can look at the diagram and zoom in your own time if needed, you can see how the Non-starch polysaccharides have got psyllium, which you might have heard about as psyllium husk as a supplement, or FOS, which is also a fiber supplement. So they're still fibers, but they are different types of fibers and they have a different use in the body. And then on the bottom side, we have that insoluble fiber. And what we're showing is how the matrix can be divided into different types of fiber. We're also going to use a wonderful avocado as an example of molecular structure. So when we're looking at the food matrix, it's important to understand that every single food has got an intermolecular interaction, and everything basically comes down to chemical bonds. We have carbon, hydrogen, and water bonds. Now, taking this avocado, we can see that you can extract from it some mineral compositions, which will be including some micro minerals. And you see again there the Mg for magnesium. So that indicates that magnesium is bound up in the composition of an avocado. We can also see that we can extract that fruit oil, and then following that line through, it actually gets divided into fatty acids and to photosterols. And if any of you are interested in cholesterol, you might have heard about plant sterols. So this is actually the molecular structure being broken down, breaking all of those chemical bonds to give you the end result of a photosterol or plant sterol. And we're going to use the wonderful apple as another zoomed in example of food composition. So we're looking at modifying the structure here. So focusing on the apple and that red line, the red line meaning heat, what we're looking at is if we have an elevated temperature, we can alter particle size and degrade fiber types. So an apple is really rich in pectins, which is a really wonderful fiber, but it can be really hard to digest. So if we're looking at the particle size, the sort of honeycomb shapes on this diagram, we're actually changing that particle size. We're then going through changing velocity, and what we're ending up with, if you see the red, green, blue structures, we're breaking those structures and we're actually making the pectins less branched pectins, which equals easier to digest. And this is why in the nutrition world we love a pureed apple for gut health, because we've used heat to change the structure and change the composition of that food. Now, that's the composition side of the food matrix. The next section is the digestive process. And what we're really looking for in the way we use food is looking at the digestive process basically converts foods down into simplest forms. So this is via ingestion, mechanical digestion, chemical digestion, propulsion, which is literally muscles pushing food through, absorption, which we'll go into a bit more detail in a moment, and then defecation, which is evacuating your stool waste. So blue line is carbohydrates, yellow is lipids, which is fats, and then the red is our proteins. And what this diagram depicts is everything comes in through the mouth. There's a digestive process happening there for carbohydrates in the way of the saliva called amylase. It's a digestive enzyme that breaks down that food through the chewing, which is chemical digestion. And then we have a few different breaks according to what our food is of where digestion process happen. So where we're breaking up those molecules. So if we follow the carbohydrate line down, we can see that the next lot of important relevance to our food structure is the inclusion of pancreatic amylase. So we have some more digestive enzymes, and then we go down to the small intestines. Our fats, there's a lot of involvement from the liver and the pancreas, and then our proteins get broken down from pepsin in the stomach, first of all the way through into peptides, down into amino acids through a few more processes. So this is a lovely way of showing that when people say food doesn't agree with me, it's like, well, what food and at what part of the digestive process might you not be converting your food into smallest forms? And a very, very important element to the food matrix is fluid. And you'll probably hear fluid and hydration as we go through today. And you've probably heard how important hydration is to health and very important to someone with connective tissue concerns. But did you know that the food matrix, when we consider everything said and done, requires an awful lot of fluid? So the digestive tract is involved in the ingestion and secretion of fluids, and we're going to also be absorbing fluids from the digestive tract into the body. So we consume our fluids through the food and drink we consume in orally through the mouth. We also do produce fluids as well in the body, and fluids are very, very important in breaking down foods and supporting nutrient absorption. And we can see on this diagram, we have the blue arrows and the red arrows, and you can see that there's a lot of involvement. And if you are able to see or zoom in later, in brackets, you've got a quantity of litres. So gastric secretion may total 2 litres. 92% of fluid is absorbed in the small intestines, and 6 to 7% absorbed in the large intestines, and only 1% is actually excreted through the stools. So when we talk about fluid for helping evacuate stools, it's for this whole digestive process, not that you actually have a large amount of fluid in the stool. Now, when we then take what we've already learnt about food process and fluid needs, we look at nutrient assimilation. And so this is a zoom into the small intestines, which is in 3 portions. And most nutrients are absorbed with salt and water here. There's paracellular and transcellular. And this is where a lot of malabsorption potentials might happen for people with poor gut health for numerous reasons, including complications of EDS. So in this diagram, I draw your attention to the muscle layer. That's the propulsion. So we need that squeeze of the muscles to get food through, or broken down food, sorry, that should be. We have some circular folds, and then we have the villi. And if anyone has celiac disease, you'll have been familiar with the importance of villi. Then we have nutrient absorption, and there's blood flow that goes en route to the liver. So the small intestines is really, really important in nutrient assimilation. So if we look back to the previous slides, we know that chewing is going to be important. We know that fluid is going to be important, and helping the food into smaller particles is important before we even get to the small intestines. Then we can take another step further into nutrient assimilation. Once we've got compounds into the small intestines, we're going to have some more breaking up of the structures. So the molecular structure of each different composite here, you can see has a different pattern. And we're picking phytochemicals because they're a very, very important nutrient for the body. They're plant-based chemical compounds. They are found in research to have anti-inflammatory effects, and they're very bioaccessible and bioavailable. So we're going to look at 2 aspects on this diagram. Firstly, draw your attention to the purple non-flavonoids. We can see that by assimilating and breaking down a polyphenol-based food, which is mostly all your colourful fruits and vegetables, we can break down and follow the line through, and then you'll see curcumin there. So we're changing that structure, and then we end up with the result of curcumin. If we follow the pink line of flavonols, we're breaking up the different compounds and we're ending up with quercetin. And you might be very familiar with hearing quercetin if you have EDS, particularly if you have mast cell and gut issues. And we're also going to delve into the same approach, but looking at proteins. So in the diagram, you can see the really, really lovely long ribbon with beads on. This is proteins and the protein structure. And then during the process of enzyme and acid breakdown, we're going to be breaking the ribbons effectively. And so we're changing the structure. And this is where we can kind of convert amino acids into the collagen and the collagen synthesis process. And all of this is important to enable protein breakdown for intestinal absorption. And what's important here are amino acids of glycine, proline, and hydroxyproline, a mouthful to say. And so why is all of this really important for considerations in EDS? Lots of people come to my clinic and they're wanting to feel that they can't eat enough foods and how can I increase foods, or they feel that I've got EDS so I have to have more protein or collagen supplementation, or worried that they're not eating enough protein to start with. But actually the discussion is about, is food working well for you? Do we have a really good understanding of what food is, how our body uses food, and how we can manipulate foods to better be digested? So this diagram depicts that we have um, the opportunity to optimize our chewing capacity, because we can change a structure of food to be a little firmer or a little soft according to what our chewing needs are. We can allow for a safe swallow. Swallowing will be discussed later today, but we can actually change the structure of our foods to enable us to swallow it in a more safe and appropriate manner. We can also support gastrointestinal function because we can change that physical state of food. And up there in the blue circle, we've got the molecules and the structure. So we can actually have an opportunity to change that structure before we've even put the food into our mouth. We can also help that gastrointestinal function by helping the food get assimilated better, so breaking it down easier. And all of this is going to mean that we'll improve key nutrient status, which for EDS, one of the big considerations is, can we improve collagen synthesis? And can we also moderate food intake behaviors? So it's not uncommon for people to have restricted food intakes because food is deemed bad for us or difficult to digest. But understanding how we can manipulate that food structure and the importance of the overall food matrix, we can moderate a food behavior by not labeling it good or bad, and also looking to how can we make it work better for ourselves. The sensory side here with the green circle, I shan't go into a lot of detail here because Mel in the last session today will be covering that. But we can actually have an opportunity to change how food feels for us. And actually, that can be a pleasure sensory experience as well. You know, some people like different coloured foods, different sensations in the mouth of food. And that all goes through into oral processing as well. So it's not just the joy of food in the mouth, it's also, are we going to get fatigued by chewing? Can we break down that structure? And all of these factors go in to influence how our body uses food in a psychological aspect, environmental. Can we join in social settings? Physiological, where are we being satisfied by our food because we have appropriate hormone interactions? So we're not feeling full easily because we've changed the structure before we've even eaten. And then, of course, physical. So, you know, are we actually able to manipulate the physical volume of food to improve how food moves through our system, and then hopefully have improved stool movement? So all of these factors are super, super important to consider for EDS because it allows us to use food to work well for us and hopefully mitigate any negative symptoms or improve symptoms. So the key message is, never blame the food, maybe blame how food is being chewed, digested, and absorbed. And I hope this has been quite helpful for you as underpinning some knowledge as you move through today's talks, and you'll hear about proteins and fibers and dietary interventions. So thank you ever so much for your attention.